Number 46. Find the third degree Maclaurin polynomial for f of x equals sine of x. Then calculate the magnitude of the exact error when evaluating f of 0.8 using this polynomial to the nearest 100,000th. So basically what a Maclaurin polynomial is it takes functions, in this case f of x equals sine of x, and approximates them using just polynomials. So I won't go into the derivation right now, but for sine of x, the Maclaurin expansion is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and then on and on for infinity. And basically, the more of these that you add on, the closer you get to sine of x. And so if you went all the way to like x to the n divided by n factorial, then you would get an exact answer for sine of x. But here, it says find the third degree Maclaurin polynomial. And so the third degree refers to the power of the term. So in this case, our third degree Maclaurin polynomial is just going to be, it's going to stop right here, where we have the x to the third plus 3, or x to the third over 3 factorial. It doesn't refer to the number of terms, it refers to the degree of the term. So the degree of x cubed is just 3. So if you want to find what f of 0.8 is, it's pretty straightforward. You just say 0.8 minus 0.8 cubed over 3 factorial. So I'm going to go to the calculator and see what this is. So 0.8 minus, then fraction 0.8 cubed over 3 factorial. And let's see, so we get 0.714667. So what the problem is asking for, we're looking for the error whenever you approximate sine of 0.8, like this. So if I find the sine of 0.8, so I go to trig sine of 0.8, and then subtract out my approximated value, this should give me the error. So the error looks like it's 0.00269. And that is answer choice C. There's actually a way you can do this on your calculator. There's a way you can find this Maclaurin polynomial in case you forget what the expansion for different things are. So you can go to your calculator, and then it's menu, 4 for calculus, and then series, and then see it says Taylor polynomial. A Maclaurin polynomial is just a specific kind of Taylor polynomial. So this is what you do. So your first expression, you just put the thing you're trying to approximate. So in this case, it's sine of x. Then you put the variable that you're working with. Since it's sine of x, my variable is just x. And then you put the order of your polynomial. So in this case, it's 3. Then there's an optional argument where you could put where it's centered around. So basically, whenever you have an approximation, it starts and is the most accurate at a certain center. But for a Maclaurin polynomial, that number is just 0. So I could put comma 0 here for a Maclaurin polynomial, but it's just, if you don't put it, it just assumes that it's comma 0. So right here, if I click enter, look, I get x minus x cubed over 6. And so you can use this if you ever forget what the different expansions for the different functions are. Yeah, so we get the same thing. You plug in 0.8, do sine 0.8 minus 0.714666, and we end up with the same answer. So it looks like we're going to end up with answer choice C. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I'll see you next time.